Now we are going to start part 2 of lecture 4. You remember that we started for data fundamentals. In the data fundamental, we start after introduction, understanding of data as a fuel, and then our discussion will be a start from data classification. If we finish data classification, we can go to the evolution of data collection and preparation. So data fundamentals, data classification as a last part. Just I would like to remind you what we are going to talk. So data classified usually as a three part: structured data, unstructured data, and semi-structured data. In this slide, we are going to explore the three major types of data. This category is essential because the way data is organized directly affected how easily we can process and analyze it. So let's start with structured data. So structured data is a highly organized, often stored in the fixed format like relational database. Think of a spreadsheet with the rows and columns. So mostly is a relational database, right? Each piece of data, when we consider a spreadsheet with rows and columns, each piece of data fit into a specific category. Example including tabular data from database, XML documentation, or CSV file. If I give you an example, imagine a database of customer information for online store. Data is structured into columns like customer name, email, order history. This format makes it easy to search and run queries to pull out useful information, such as how many customers made purchases in the past week. The primary advantages of structured data is that it is easy to analyze due to its predefined schema or structure. Tools like SQL database are specifically designed to handle this kind of data efficiently. So this is the structured data. Let's dive into unstructured data. On the other hand, unstructured data doesn't have a specific format or predefined structure. This includes things like social media posts, images, videos, file, and text document. So text and like videos. While this data is rich in information, it is much harder to analyze. You know, in the DIKW pyramid, remember, we have a like data part and then information. So while data is rich, then we will have very difficult to get the information. And it is, on a structured data, it is compared to the structured data, it is no clear ways to categorize it up front. Let's give you example 2 for unstructured data. Think of collection of user generated content. User generated content is famous. Remember, user generated content means in any weblog, any website, when the user give comment, which is based on web 2. Remember, if I quickly say we have a web 1.0, we have a web 2.0, we have a web 3.0, we have a web 4.0. So when we say web 1, web 2, and then web going to web 5 like that. Web 1 means like design homepage. The user cannot put the data, just read. Web 2 is like some shopping website user can put some comment. So it's a two-way. This is one way, web 1. This is two-way. User also can participate. User, as I mentioned, user-generated content is in the web 2. And web 3 is a semantic, and web 4 is a smart, like IoT based and a smart system. Semantic means meaning, because web 1, web 2, computer, HTML in the front end part, HTML, CSS cannot understand the word because that is code, but in the web 3 can understand. So many things related to, I don't want to go that one because it is big topic. Just come back to the example of unstructured data. Let us collection of user-generated data such as user review. The reviews contain valuable insight, but they are all different lengths, use different wording, because every user giving different sort of way to add the content, and may even contain images or video. There is no simple structure to run a query, against this sort of user comment. Analyzing this requires more advanced technique like NLP. So in that case, we need NLP. NLP, it is unstructured data. NLP is natural language process. Because unstructured data lacks a predefined format, we often need more sophisticated algorithm to extract useful insights, like machine learning algorithm for text classification or computer vision techniques for images and videos. So let's go for semi-structured data. Semi-structured data, which is mix of both of above item. It contains organizational markers that makes it is easy to analyze than unstructured data, but it is not as rigid as structured data, somehow between. Think of document like JSON or HTML. These some structure, but the actual data within them can vary widely. So let's give the example 3 for semi structured data, imagine JSON file that store product data. The structure tells you what each item represents. Like what? Like product name, like price. But the actual data can vary, not fixed, and can change. And it is less formal than a relational database. It is more flexible, but still has enough organizations to be processed relatively easy. So, semi-structured data stored in the file system, like NoSQL database. So as a summarizing our discussion, to summarize, structured data is easy to analyze but rigid. Unstructured data is more flexible but harder to process and analyzing. Semi-structured data lies somewhere in between. Each type of data requires different tools and techniques to handle efficiently. As a data scientist or AI professional, understanding how to work with these all three types is crucial. Okay, I think this is enough. We don't have time to much touch to this sort of data fundamental. Let's dive into second part of section 2, which is data evolution and data evolution of data collection and preparation. So the next important aspect of the evolution of data collection and preparations, over time, data collection techniques have advanced dramatically, shifting from manual entry and punch card to today automated AI-powered data ingestion system. We have transformed from basic batch processing to real-time data streaming, enabling much quicker and more flexible method for preparing and handling data. Especially these days, data preparation is largely automated and with the sophisticated tools and AI used to clean, transfer ready data at a remarkable speed. So we are going to see this evolution. Before going inside, I would like give you one question. How have data collection method evolved over time? Pause and think. Answer, you can see from image which I put, somehow evolution. Initially, data was collected manually using the punch card, evolving to electronic system, and now AI automating data preparation. Each state reduce manual. Each state, if you see each state, reduce the labor work and improve accuracy, allowing us to handle large data set with a greater efficiency. So this evolution, if we look at evolution, we will see that in the before we dive inside to each one, quickly in the see some point, in the early days, data collection has come a long way since pre-19th, when the manual method like punch card were the standard. In the early days, data collection were labor-intensive, error-prone, and slow. This is the point. So then rise of the electronic computers. In the 1915 to 1917, the introduction of electronic computer revolutionized data handling. During this time, mainframe computer allowed for the faster processing of the large data set, shifting from punch card to magnetic tapes of the data stage. So I am just putting the one page whole, and then we will quickly inside. You see first from here and then go rise. So question come here. What challenges did early electronic computer face? Can you imagine which challenges? Pause and answer. While faster than manual method, this system still struggled with real-time processing. So this was digitalized, but real-time processing and data cleaning remained largely manual. Here, data manual. This is the online and data processing largely manual. However, they laid groundwork for the more advanced system we have today. So next one, personalized computer and spreadsheet era. When you go 1918s to 1919s, when we saw the rise of personal computers and software like spreadsheets, this is during this period. This period demonstrates data handling, allowing individuals and businesses to manipulate and analyze the data more efficiently. Spreadsheets like Excel brought data analysis to the masses. With just a few clicks, you could organize and clean, analyze your data in the Excel file, reducing barrier to entry from data analyzing. During this era, also introduced basic data cleaning tools like find and replace, with greatly improve efficiency. So let's say another step. Explosion of the internet in 19 to 2000s introduced new method of data collection. The web became a vast source of understanding data, from blogs, social media, requiring new techniques like web scraping to collect and analyze data. One question come here. Please, ready to pause. How did the internet change data collection practices? Pause. Answer. The internet provided an immense amount of unstructured data. Remember, unstructured data, forcing development of new tools and techniques for scraping and cleaning this web data. This marked a shift toward more complex data handling. And then fifth stage is a big data era. This is a start from 2000 to 2010 technically, but many people still is ongoing. Still big data is advanced one, but mainly focused this time, it was very hot topic. During this time brought the era of the big data and rise the advanced ETL. What is the ETL? ETL stands for extract, transfer, and load. ETL tools become critical for managing large and complex dataset. The sheer usually big data basically start with the 3V: volume, velocity, and variety. Then go for 4, 5, 6, 9 something. So the sheer volume, velocity, and variety of data in this era, needed a new approach. Tools like Hadoop, NoSQL database enable a company to scale data handling efficiently, allowing for distributed processing and store across multiple servers, even only during this time. And in the last part, modern AI-assisted data preparation. Today, AI is a transferring data preparation through automation. AI-assisted data cleaning and preparation tools, here when we talk, can identify anomalies, fill gaps, and optimize data set in the real time. When we talk about the modern tools, like Google Cloud Dataprep or AWS Glue, Amazon, can these days handle bulk of data preparation automatically. Machine learning model can help, detect outliner, automated data cleaning, and even suggest correction, reducing the time and effort needed for manual data preparation. So, as a recap, what we discussed for evolution of data collection and data preparation, understanding this evolution is a key appreciating tool system that we have today. How they have developed to meet increasing demand of modern data management. So this is very important. And so you see from manual record to AI assistant, if we summarize it. So we will see a manual record simply to lead the development of punch card and early processing. With the rise of electronic computer, data handling become faster, more efficient here. Personalized computer revolutionized data collection and, accessibility. Internet and web, data exploration open doors and unprocessed amount of data here. In the big data, such as big data, many techniques I mentioned like Hadoop or other thing, Spark, are used for data preparation. And then we come to the AI assist. So I simply make in some sort of keyword to make very good journey from how data is happening from here to there. So the first part, which it was the early days. So you can see origin start from ancient record keeping system. So everything was manual. So from ancient time to the invention of punch card. Who invent? By Hollerith from 1819's US data was collected and stored in the fixed format. So character, it was manual entry, fixed format, and each punch card typically led up to 80 character. So in the development, milestone like Roman census and IBM's improvement in the punch card. So what is the limitation of this era? It was a slow and labor-intensive and prone to human error. So I think is enough. Let's go for the another era. So rise of electronics. In this period, we see the introduction of mainframe computers, which revolutionized data processing. The key innovation like batch processing and the magnetic tapes storage allowed for faster handling of large datasets compared to the manual method. So if we say key point for here, faster data processing and store innovation help the business store, but there is some limitation. Data cleaning was still manual and real-time processing was limited. Despite of this limitation, this development laid on groundwork of modern data management system, enable more efficient data handling and setting the stage of future breakthroughs. Another, relational database. In the relational, we will start with the introduction of Edgar Coates' relational model in 1970. Data management took a significant leap forward. The relational model allowed data to be stored in a table with defined relationship and making it easier to organize and retrieve. This led to development of SQL, structured query language SQL, a powerful tool for interacting with a relational database introduced by IBM in the mid-1970s. SQL soon became the standard of query updating, managing database, which is still widely used, even nowadays. So, the key innovation, ACID, which is a stand for atomicity, consistency, isolation, and durability properties, were crucial in ensuring data integrity during the transactions. These properties made it possible to handle complex data operations with the reliability. Major systems like IBM System R 1974, Oracle version 2, help bring the relational database into the mainstream usage, providing robust system for the business to manage their data. And in 1995, MySQL was introduced, become one of the most popular open source relational dataset. So relational dataset allow business to organize vast amount of data efficiently. Use of SQL provide a standard way to query data, making data management simpler and more powerful. This era laid the fundamental of what modern database system management. What is the advantages of modern database system management? That is efficient data organization, data consistency, and standardization. When we say data consistency, means ACID properties ensure that data remains reliable and consistent even in the large-scale business operation. So when we talk about the standardization, SQL became as a standard query language, which meant that professionals across the industry could use the same language to interact with the database. So really, a relational database revolutionized how business manage and utilize their data. They allow compare to store structure efficiently, maintain relational between data points, and use a complex, traditional securely. These evolutions in the database management enable industry to perform advanced data analyzing. So this characteristic to make informed decision based on the real-time data. So let's go for the another era, which is the personalized era, which is a start from 1980 to 1919. The rise of personal computer and spreadsheet software revolutionized data handling. Tools like VZ Clock and later on Excel that made data entry and analyzing more accessible and not specialized, allowing any individual to manage and manipulate data without need deep technical expertise. So key innovations is the spreadsheet software and data management system, which is called DBMS, like DBase, Oracle, provided more backend system for large organization, allowing for more structured data management. So introduction of user-friendly software changed the landscape of data handling. Basic tasks like sorting, filtering, cleaning of data easier. These tools empowering users to work with the data directly. This era really we see as an early development of data cleaning function, like find and replace and sorting, which is revolutionary actively for us. Some advantages: democratization and generalization of data management, which is more efficient, is available. So impact of this era changed many business researchers and many advantages. So internet and web. So in internet and web key innovation is the web scraping and online surveys and forms. So these two innovations. This era also introduced unstructured data format like HTML. HTML, which is post challenges for data extraction and cleaning. Developer started using tools like, regular expressions to clean and process this data for analyzing. So some challenges. One is the inconsistency of web data format. Made cleaning and preparation data more difficult and requiring advanced technique. And another is the scaling data collection. It was a challenge of volume of web data. And impact, this era opened a door to vast source of data and driving new techniques. And big data era try to expression of data, volume, variety, and velocity, 3V. So drives of the big data era, we need to handle vast amount of unstructured data, and semi-structured data became critical. And scalability and flexibility in the data processing system were essential for managing large and complex data set. So regarding data innovation, one of most important advantages was the rise of ETL, extract, transfer, load. Tools like Talent and Informatica, which streamlined the cleaning, transformation, and integration of data from diverse sources. Then another key innovation is the Hadoop ecosystem become crucial for distributed data processing, allowing business to process what? Huge number of data across the cluster of computer. And then emergence of NoSQL database revolutionized how we store and retrieve data, unlike traditional relational database. NoSQL database like what? Like MongoDB, like Cassandra, Neo4j offer more flexibility in handling document-oriented key value and wide column and graph data model. So characteristic of NoSQL system, NoSQL introduced a schema-less structure, making it is easier to scale database across multiple servers. And many NoSQL database implemented eventual consistency instead of strict ACDI property seen in the traditional SQL database. This trade-off allows for faster operation to large distributed system value, still maintaining acceptable level of data consistency. So as continuing for big data, there is advantages like efficient handling. NoSQL system provide efficient handling of unstructured and semi-structured data, unlike traditional SQL dataset that are confined and structured data model. Scalability. One of most key benefit is improved scalability for both data preparation and storage tasks, making it easier to process large datasets. Another is the performance. This system offers better performance, and such as real-time processing, which is vital for industry like finance and e-commerce. Flexibility in data modeling and storage is another critical advantages. No SQL system allow for storage of diverse data types without needing predefined schemas, making this adaptable to wide range of application. Impact. Impact is big data analytics, focus on data query, and revolutionize storage and retrieve, like NoSQL database revolutionize data storage and retrieval for web scale application, paving the way for more agile and distributed system. And more distributed and cloud-based system, this technology enabling companies to scale globally and handle large amount of the data across the different locations. So, and as a last part, which is modern AI assistant, preparations. So if you look at this one, you can see some origin integration of machine learning data into the data preparation process. Key innovations. This era saw the innovation of machine learning into traditional data processing with the tools like perform AI assistant data cleaning and anomaly detection. For example, AI system can now identify outlier in data that may previously gone unnoticed. So another key development is automated entry resolution and deduplication, which help ensure that the integrity of data by identifying and eliminating duplicates across the dataset. And the NLP are also being used to clean and process structured data such as text, social post, and log, enabling business to extract insight from data that was previously difficult to work with. Technology is like Google Cloud Dataprep, AWS and data preparation limitation like pandas in Python. So we will, if you want, R is a tiddlyverse. So we will touch in pandas during the coming lectures. So characteristic, so the key characteristic is automation. So it's very important. Real time and integration is very important. Challenges. So despite the benefit of this era, there are challenges that ensuring data privacy and security in the highly automated system. For this one. So balancing automation with the domain expertise is also essential. While AI can handle many tasks, human oversight is still needed to make a sense of, some data context. So in some use case, like this is the last slide of the evolution data collection. Then we will go for evolution of big data. So after this use case I explained, we will finish this video. So healthcare industry. So automating medical data cleaning. Example. If I give you example, a healthcare provider collects patient records from the multiple sources such as hospital, clinic, labs. With the AI assistant data preparation and AI tools like Google Cloud Dataprep can automatically clean and merge this data, removing duplicates and standardizing data format and easy analyze. What is the result? Then this process reduces the time spent on the manual data cleaning and improves the quality of the medical data used in the machine learning model to predict patient outcome and recommend treatment plans. Another example, retail. In the retail, large retail company gather customers, information, such as AWS Glue, DataBrew, is automatically resolve duplicate customer record. Like what? Like customer who have shopped both online and in a store, ensuring a single clean profile of each customer. What is the result? This improves accuracy of the customer analysis and leading to more personalized marketing strategy and target product recommendation. Another example is the e-commerce NLP for cleaning unstructured text data. An e-commerce platform collects vast amount of customer feedback in the form of unstructured data. So, like, if AI-driven NLP model such as Python's in NLTK or SPA-SCI library help clean, classify and extract useful insight from these customer review. The result for this one, the platform can analyze sentiment, product performance, and user behavior, helping optimize marketing and product development based on customer feedback. Finance is a real-time data preparation for fraud detections. So AI-driven tools such as Talent or Apache Kafka can clean and prepare streaming data in the real time, identify outlier and potential fraudulent activity using machine learning model. Result will be increase the efficiency for fraud detection. And the last, logistic AI assistant data transfer for data supplement. So the logistic company can use many data GPS, like GPS tracking, inventory level, shipping schedule, all can be multiple data source. Assisted for data preparation tools like Informatica. This is the tools. Automatically merge and clean these sort of data streams and transferring into the classified or ununified format suitable for machine learning. What is the result? That is, clean and transfer data can be used to predict supply chain bottlenecks, optimize delivery schedule, and enhance overall operational efficiency. So this is the use cases of modern assistant. We finish the evolution of data collection and preparation for part 2. In the part 3, we will touch the evolution of big data.